DBCO is an international project supported by the 2020 Horizonte program of the European Committee, implemented by the GIZ in cooperation with 13 organizations with experience in 4 continents. The main goal is to establish a closer cooperation between technology European suppliers and biogas stakeholders in participating countries. The project works through different initiatives like a digital platform, seminar development, technical meetings and visits to plant in different countries. On their website you can access to different documents, dossiers and developed webinars.
Bueno, la segunda visita del proyecto DBCO a las plantas de biogás en Argentina. En este caso nos acercamos a Christophersen, ciudad del sur santafesino, pleno núcleo productivo argentino, a uno de los tambos más grandes de Argentina, que cuenta con freestall, vacas estabuladas y todo un sistema de tratamiento, fundamentalmente en este caso para esta planta específica, alimentada con estiércol de vacas lecheras, y todo un planteo también de aplicación sitio específica y coordinada en cada uno de los lotes de los biofertilizantes que salen de las plantas. Dicho esto, los invitamos entonces a comenzar la recorrida por el tambo de Adecoagro y las plantas de biogás.
Adecoagro has 4 modern units for milk production with 3,500 dairy cows in each one, where more than 200 tons of manure per day are generated. The venture has a total surface of 10,000 hectares, of which 7,500 are dedicated to the dairy farms. The units have 14,000 cows in rebreeding, 4,000 potty calves and 14,300 cows in production. They are milked 3 times a day in 4 milking halls with a system called carousel with capacity for 500 cows per hour. This way, more than 170 million liters of milk are produced, reaching an average productivity of 37.5 liters per cow per day. This business employs more than 300 workers, 96 of them focused on field labor. For an optimum waste treatment, the biogas plant was assembled in situ. It is made up for a biodigester that is capable to process 220 tons per day. 200 tons of manure and 20 are farm animals' food waste. With this raw material, they generate 1.4 megawatts-hour of electric power and 140 cubic meters of biofertilizer. They also generate liquid fertilizer with 3% of dry material, directly derived to irrigation with fertilization. Each dairy farm contributes approximately 20 cubic meters per hour. The process starts in the barns, where they collect the manure by 2 systems, one with mechanical sweep and the other by decantation through a stream of water that smooths the material. Then, this mix is driven to the solid separating machines, where the water is extracted and the manure is separating within the 15% of dry material. This material enters to the primary fermenters, the F1 and the F2. There, the new material is mixed with the existing one to start generating the biogas with hydrogen sulfide qualities below 200 parts per million and a methane concentration ranging between 50 and 55%. In the primary fermenters, the 80% of the biogas is produced and the material rests at least 20 days. The mix from the primary fermenters is pumped to a third tank called post-fermenter. It is a tank just like the others, only that the material arrives more digested. The remaining 20% of the biogas is generated here. The biogas is combusted in a generation engine and derives into electric and heat power. The thermal energy is used to heat the digesters, keeping a temperature of 43 Celsius degrees. The capacity of each fermenter is 3,500 cubic meters and has 4 mixers that move up and down to avoid decantation and crusting. The average production of biogas is around 15,000 cubic meters per day, and this generates 32 megawatts that are injected to the national energy system. The delivery company is connected to the plant and makes a continuous monitoring about the quantity and quality of the power given to the system. On the basis of these records, the company receives the funds for the sale of electricity. At the same time, they get a fertilizer as a sub-product in solid and liquid phase. Now let's tour every part of the systems and the equipment in detail. The animals stable in free stalls with beds of sun go dropping to a particular sector in the corral. They go there to get feed. The floor is slotted concrete and the manure gets accumulated. The barns are cleaned 3 times a day with 2 systems. The mechanical sweeping consists on a conical elevator added to a tractor. It has a rubber band on it. Actually, is a tractor tire, cut and inverted. When the animals in that corral are out of milk, the machine goes slowly through the floor, pushing the manure to a slotted sector, where it falls to the collector pools. The other system is hydraulic. It is used in barns designed with a higher slope. On the special floor that comes before the top, a great stream of water is launched, about 150,000 liters. Thanks to the sloped floor, the water gets special speed to clean up all the material to a collector pool located on the lower extreme. For a better exploitation of this manure, there is a project to build more biodigesters. The stable animals sleep in beds made of sand. This improves their comfort and so their productivity. But this material represents a big challenge for all the processing system, since some sand is mixed with the manure, so that it must be separated and conditioned to reuse. The swept material in the barns falls by a slotted sector to the collector chambers. They are connected to equalization containers. The fluent goes for subterranean sewers and reaches to an equalizer chamber, whereafter it goes through some decanters, which main function is the sand sedimentation, the base material in the cow's free stalls. After the decanters, the processed effluent goes through different kind of separators, where the solids turn into substrate and the liquid is split. One part of it enters to the biodigester as diluted water, and the other part goes to the treatment ponds to be later distributed through fertilizing irrigation. The manure is complemented with some other kind of residue. They vitally increase the biogas production in the digesters. These materials are mixed before entering the digester. They are technically known as co-substrates. The mix that finally enters for the process is made in a 91% of manure from the milking cows, about 8.6% of the silage, taking advantage of the silage in poor condition, more the food remaining, with 0.4% of glycerol to 60%, coming from different biogas plants. This means that 200 tons of manure are being supplied per day, 20 tons of rejected material and silage, and 1 ton of glycerol. Also, 25 kilograms of nutrients are added to improve biogas production inside the tanks. This is made through a specific dosage system provided by a specialist sanitation company. The solid part precipitates to a hopper. It dilutes with water by pumping and it's stored in the charging chamber, which has 2 open equalizer containers. The material enters the fermenters 1 and 2 with an 8% of total solids. Each digester has 2 mixers with 15 horsepower and 2 mixers with 20 horsepower, whose purpose is to keep moving the biomass that is being processed. These mixers are equipped with systems that allow varying the direction of the inner fans that produce the material mixing and homogenization inside the fermentation tank. Average hydraulic retention time, ergo, the permanence of the biogas inside the biodigester, is 14 days. During all that time, different types of bacteria are decomposing the raw material and release main gases such as methane and carbon dioxide. The facilities currently operating have the capacity to process 50% of the residue generated by 7,500 milking cows, so that the construction of a new plant is being planned. The main problem they face is the accumulation of sun in the digesters. Once every 2 years, they must be emptied to make a preventive maintenance, allowing them to be put back into running. In this work, they usually extract between 1,000 and 1,500 square meters of sun from the fermenters. To get an optimum transformation and a good biomass production, it is required to maintain a certain temperature inside the biodigesters. It must be warranted by the help of external agents, since the reactions do not generate heating. Here, a part of the heat energy produced by the generating engines is used to keep the required heat inside all the tanks. 3 pumps are responsible for supplying hot water at 75 degrees in order to maintain the proper range of 43 in all the digesters throughout the year. The water travels through the heat exchangers. They recover the energy contained in exhaust gases, engine cooling ducts, and the internal coils of all the tanks. The temperature is permanently controlled. The automotion and control system allow to achieve the stability inside all the tanks, independently of the external temperature. The system is completed with the help coming from the isolation of all biodigesters, avoiding energy losses. Biogas requires a series of processes before the use in combustion in generating engines. Inside the biodigesters, air is injected in small proportions in order to get in the specific bacteria catch the most of the generated hydrogen sulfide. It is stored in inner networks that, at the time of the digester opening during the periods of maintenance, can be removed and cleaned. When the gas exits the digester, is filtered by 2 systems, one of gravels, which are stones between 30 and 60 mm, and the other is a ceramic filter. Then it is cooled by a heat exchanger with cold water called chiller, where the temperature of the gas is reduced to 2 degrees Celsius, and the moisture content is extracted by means of a cyclone. Finally, in a blower, the pressure is adjusted from 20 to 200 millibars to feed fuel to the generator engines. The average biogas composition is 52% methane, 47% carbon dioxide, and 0.3% oxygen, with 111 parts per million of hydrogen. The average production daily pace is 1,087,995 cubic meters per hour of biogas. They generate 1,563 kilowatts. The fermenters 1 and 2 produce 80% of the total daily generated gas. Biodigesters are remotely monitored and operated by means of a general control room that receives all the data. From this room, they can be activated different actuators, pumps, engines, and mechanisms in the way to achieve an optimum fitting, temperature holding, so as well the values that make it runs. All the collected data streams online, also allowing remote monitoring of the plant operation. Each plant must have a number of internal combustion engines specially adapted for a continuous operation with biogas. In the case of Adecoagro, both owned and rented equipment for the power generation are available, since different alternatives are being tested. The engines are inside specially prepared containers to reduce noise and strong temperature fluctuations. Every engine has an established maintenance plan in order to guarantee an optimum operation, avoiding breaking and failures that would cause the interruption in electricity generation. In case of an eventual engines out of service, there are security torches that light with the gas that cannot be used, thus avoiding the release of unburned methane into the atmosphere. The digestate out of the digesters is separated by a screw press that processes approximately 140 cubic meters per day, 60 in its solid phase with 20% dry matter and 80% in the liquid phase with only 3% of dry material. The liquid part is stored in the pools. The land has 5 pools, so only 3 in use and 2 in reserve. The liquid digestate is sprinkled in their own land. For this, they have pipelines and central or forward irrigation pivot, as well as manure tank cars. The liquid is applied on different farming, foraging grasses such as maize and sorghum in the summer, and topics or greens for silage in the winter. The solid part is delivered to different plots of the land through solid manure spreader trailers with high capacity. They are developed to make a homogeneous distribution of the fertilizer on the surface.